Alright, so now we're going to talk about another type of function which have vertical asymptotes. So vertical asymptotes do not only occur when the denominator of a function is equal to 0. Some functions have actually vertical asymptotes in their definitions. And this is the case of the logarithmic function. Let's have a look at the most famous example. If summer wasn't too hard on you, you should remember it. F of x is equal to ln of x. Okay? So the way it looks like, so let's sketch its graph. Okay? Actually, the graph of the logarithm is what I'm expecting you to remember is that ln of 1 is equal to 0. And just for you to actually remember, like that the ln is the base e. So when x is equal to e, y is equal to 1. This you also need to remember. You need to remember like what a logarithm means and how to sketch its basic behavior. And it does something like this. All right. So this is your curve, like f of x equals ln of x. Okay, the first thing I would like to say about this is that whenever you try to approach 0 from below, then there's no curve to approach, there's no curve to use. This is because negative numbers are outside the domain of the logarithmic function. So here, the limit does not exist for a very simple reason. We cannot take x to be smaller than 0. So the limit as x is approaching 0 from below of ln of x is equal to dne. And this is because negatives are outside the domain. So actually, let's write it over here. Limit as x is approaching 0 is dne, since negative numbers are outside the domain of ln. Okay, of the ln of x function. Okay, so now I'm going to erase this which I just wrote underneath. But the green arrow is really what I mean. There's no curve to take, so you cannot take that limit. However, you can take the limit from above. Okay, so you do as usual. You look at the curve. What is the curve doing? It is sinking without bounds. Okay, so as x is approaching 0 from above, the logarithmic function decreases without bound. So as a result, the limit as x is approaching 0 plus of ln of x is negative infinity. Okay, so both of these limits, you can read them from the graph. Okay, this is true for ln of x. What about other bases? Okay, so what about bases other than e? Okay, so what I mean by this is, what about, for example, log 2 of x? Or log 3 of x? Right? So what about these bases? Like, how do we know if the limit will be negative or positive infinity? So, okay, I'm going to erase everything except the question, and I'm going to answer it at the top. For these bases, use the change of base formula. And I'm going to recall the change of base formula. Very simple. Log A or log B. Yeah, log B of A is equal ln of A over ln of B. Or actually, let's put x here in order to be even more precise. So this is going to be ln of x over ln of B. And then you deduce from there, from using the ln. Okay? And deduce the result. So let's have a look at one example. Let's say that I wanted to find the limit as x is approaching 2 from below of the log 1/3 of 2x minus x squared. Okay, so log at base 1/3. So how would you do this? Okay, the first step is going to look a little bit different. And I'm going to outline this in the next video, but I'm going to just tell them to you right away. Okay? So step number 1, okay, we're going to replace every x by 2. And if we have some logarithm of 0, it will mean that we have the vertical asymptote there. Okay, so we replace log 1/3 of like 2 times 2 minus 2 squared. And this is indeed giving us log 1/3 of 0. Okay, so before going any further, I should say that this indicates that you have a vertical asymptote there. So this indicates the vertical asymptote. Okay, then what do you do from there? You use the change of base formula, okay? Or actually, yeah, use the change of base formula right away, okay? So I'm gonna just write it in green. What we do is we change the base. So we use we use basically the formula as is. We have like ln of 2x squared minus ln of 2x minus x squared divided by ln of 1/3. Okay. Now I'm gonna erase this. So we're gonna continue the problem below. The second step will be very, very similar. Or I forgot the limit. Okay, so I will erase this and I will put the limit. So limit as x is approaching 2 from below of, that's it, ln of 2x minus x squared divided by ln of 1/3. Okay, now step number 2. It's going to be the same kind of step number 2, but instead of factoring the denominator, you're going to factor the inside of the logarithm. So in other words, this. Okay, so I'm going to do it. We have the limit as x is approaching 2 from below of ln. And here's the result of the factoring. It is like simple, like that's it. It's a very simple common factor. There you go. So this is what's inside the ln. If you want, if you like fractions, it's not really nice. So if you want, you can actually use the properties of the logarithms to simplify this. But I feel comfortable enough, and I will tell you why later on, to just leave it as is. I'm going to leave it as is for the entire time. Okay. At this point, step number 3 will be the exact same thing. So in other words, we're going to replace 2 everywhere except for that one factor where we're going to replace the 2 minus. Okay, so x is going to be replaced with 2, but here you replace with 2 minus 2 minus. Okay, so this is the only factor in which you do this. And then we have ln of 1/3. Then after that, you keep track of the sign that's inside the logarithm, okay? And you will see why as we do it. But what's important to realize is that this number right here is approaching 2 from below. So it's going to be like 1999, 1.1999999, something like this. So as you subtract it from 2, you're going to get a positive number, okay? So you're going to get here ln of 2 times 0 plus. I'm writing 0 plus. This means a number that's approaching 0 from above. But more specifically, the information that we're interested in is that is a positive number. That's it. Okay? Then, okay, so now another thing that's important, and I'm going to write it right away. We have like ln of, so 2 times a positive number will give us a positive number. Okay, so I will just write a little bit shortly why this step is important. So the reason why this step is important to do is because what we just saw with the ln is that, like very, very informally speaking, we did the limit from above, ln of 0 plus. So yeah, actually, let's write the full limit. We have that the limit as x is approaching 0 plus of ln of x is equal to negative infinity. And we have that the limit, I have no space to write it now. Okay, so I'll actually write this a little bit more a little bit higher. So we have that the limit as x is approaching 0 from the top of ln of x is equal to negative infinity. And from the other side, remember that if we ended up with 0 minus, the limit does not exist. So getting this 0 plus here is important just to know if we have an infinite limit or a limit that does not exist. Okay, now is the time to figure out the overall sign. Okay, so if we just look at the top, we have like negative infinity, like we have something that has a negative sign. Now let's have a look at ln of 1/3. What you need to remember with this is that ln of 1 is equal to 0. Before 1, it's going to be negative, okay? This you need to kind of remember. So ln of x is smaller than 0 when x is between 0 and 1, okay? So this means that this is negative. Okay, so when you look at the entire thing, this sign is overall positive. And as a result, the final answer is infinity. All right, I hope this was helpful. In the next video, I'm just gonna write down the method, like the method that we used over here. I will write it down for logarithms. See you there.